This skill module covers hydrocarbon components and physical properties at the core knowledge level. This section discusses why this topic is important. Recognizing basic properties of natural gas and liquid hydrocarbons, such as relative density and molecular weight, are required for basic engineering calculations. In addition, being able to do simple gas conversions using standard conditions is critical to facility engineering calculation accuracy. Liquid conversions are important as well. Common conversions used in gas processing will be reviewed in this module. Understanding the basic terminology and hydrocarbon compositions that are flowing into gas processing facilities will allow you to better communicate with your project teams. In addition, it will allow you to better understand gas compositions and properties at a basic level. Hydrocarbon analysis and C6+ characterization can be one of the biggest challenges in new field development. Adequate well stream sampling and analysis must be done to ensure that the phase behavior of the inlet fluids are well understood. If we do not have adequate sampling, or if the C6+ characterization that is used for the facility design is incorrect, the risk becomes that the facility may be undersized for liquids handling if the C6+ characterization is too light, or possibly much too large if the C6+ characterization is too heavy. An adequate extended analysis and reliable C6+ characterization parameters will ensure that the facility design for new field developments will be sized correctly for the fluid's composition and phase behavior. If we get the analysis wrong, the facility could be significantly oversized or undersized as a result. In addition, you may end up in the two-phase region where you were predicting only a vapor phase. That is particularly problematic as the system would not be designed to handle liquids in that case. The business impact of getting these wrong range from increased capital cost, lost production due to the inability of the facility to operate at designed capacity rates due to inadequate liquid handling capacity, or if the liquids are not there and the inlet fluids have a lighter composition, then the plant could be grossly oversized, an increase in capital investment with much smaller profit margins as the result of lower liquid recoveries. If acid gas components are not analyzed for in the inlet fluids, then it may be possible that the produced fluids, which are water wet, are more corrosive than the metallurgy of the plant was designed to safely handle. This could result in increased corrosion, increased operating costs due to needing to add corrosion inhibitor, or even piping and equipment replacement. Knowing the physical properties of fluids in our processes and equipment are critical to do any type of facility engineering calculation or analysis. We must use the properties of the natural gas and hydrocarbon liquids at operating conditions, not at standard conditions, as nearly all of the processes in our facilities are operating at elevated pressures. If we have the correct physical properties of our fluids, that will allow us to look inside the pipe or equipment and allow us to calculate critical parameters, such as fluid velocity, actual volumetric flow rate, etc. Correct physical properties are required to troubleshoot, size, and design any process piece of equipment or piping. Incorrect physical properties applied to these calculations will lead to incorrect results and conclusions. The business impact of not using the correct physical properties in equipment selection can result in selecting an inadequately sized separator or compressor, for example. This can result in loss in process efficiency and may have an impact on the amount of production that the facility can process due to inadequate actual capacity. On the other hand, there is also a risk that the facility is over-designed, resulting in excess capital expense due to purchasing equipment that is too large. Using the wrong physical properties when troubleshooting plant operating problems will likely not lead to the resolution or fix of the issue. This section of the core skill module introduces the concepts that underlie physical property correlations. Physical properties, such as density and viscosity, are important because they are used to size equipment. Density is used to calculate actual volumetric flow rates, which in turn is used to calculate velocities inside piping and vessels. Viscosity is an important property used for sizing piping, separators, mass transfer equipment, and heat exchangers. Phase behavior is important as it tells us at the various operating conditions whether our fluids will be in the vapor phase, liquid phase, or two-phase region. Qualitative phase behavior allows us to understand where the process is operating in relation to the fluid's phase envelope. Flash calculations are critical in process simulations as they will predict not how much vapor, how much liquid, and the composition of each stream. In addition to physical properties, thermodynamic property correlations allow the prediction of phase behavior and the calculation of energy changes in systems. These thermodynamic correlations require accurate prediction of fluid density, which is almost always provided by an equation of state. Equations of state will be discussed in more detail later in this section. This skill module discusses the topics shown here. You may also be interested in these gas conditioning and processing principles skill modules.